In this video, we are going to explain the second part of the lesson, which is mechanical waves. In this part, we are going to cover the following objectives: defining a mechanical wave, classifying the types of the mechanical waves, and characterizing the waves, in addition to solving direct applications. In the first part, we have the definition of a mechanical wave. A mechanical wave is a perturbation or disturbance that propagates in a medium, as shown in the following animation. In this animation, we can see here a certain medium. Suppose it is a rug, for example, or any other medium. Once we disturb one end of this medium, we can see that the disturbance propagates through time. See? We performed a disturbance at one end of the medium, and this disturbance propagated through the medium, disturbing the other particles of the medium, as you can see. So it started here, but it propagated, disturbing the other particles of the medium, as you can see in this animation. A mechanical wave carries energy but doesn't carry matter. As the wave propagates through a medium, it carries energy, causing the particles of the medium to vibrate, but doesn't transfer them from one position to another. So here we are showing the particles of the medium through which the wave propagates. So هون black particles or black dots represent particles of the medium. As the wave propagates from left to right, honey, we marked two particles by yellow. We can see that these particles, as the wave propagates through them, doesn't transfer them from one position to another position here, but it causes them to vibrate up and down. See? So the mechanical wave carries energy. والدليل على هيدا الشيء إنه it causes the particles to vibrate up and down. For vibration requires energy. وإلا كيف هالparticle بتعمل vibration إذا ما عندها energy? So the wave propagates carrying energy. بتاعت الانرجي لهول particles, so they vibrate up and down, but do not transfer them from one place to another. Types of mechanical waves. The mechanical waves are classified into two types: transverse waves and longitudinal waves. Let us define the transverse wave. A transverse wave is a disturbance that causes the particles of the medium to vibrate perpendicularly to the direction of propagation of the wave. Here I highlighted three terms or three phrases: particles of the medium on one side, the propagation of the wave on the other side, and their relation. In this animation, it is showing in one end of the, suppose this is a string. هيدا is a string, the black one, thick black one. So we are disturbing it at one end. وهون في عنا particles of the medium معلمينهم circularly. Okay? طيب, once we disturbed one end, we see that this disturbance propagated through the string and disturbed the other particles of the string, causing them to vibrate up and down, as you can see. وهول lines الvertical عم بيفرجونا pathway of vibration. Okay? طيب, والwave عم تنتقل from left to right, يعني horizontally. وهن they are vibrating how? Vertically. يعني horizontally و vertically, this means that they are what? Perpendicular to each other. So the direction of vibration of the particles and the direction of بنقول الwave it propagates, it moves, are شو? Perpendicular to each other. So the direction of vibration of the particles and the direction of propagation of the wave are perpendicular to each other. However, for the longitudinal wave, a transverse wave is a disturbance that causes the particles of the medium to vibrate parallel to the direction of propagation of the wave. هيدا بيعني إنه if the wave or disturbance is propagating horizontally, then the particles are going to vibrate horizontally. وإذا vertically فإذا بيعملوا هن كمان vibration vertically, just as shown in this animation. Disturbance بلشت disturbance بلشت هون